Hey math kids, today we're going to talk about growth and decay. We are in chapter 5, section D, and there's only one example, number 11. There is a blue box above the example we're going to work on, and it has this information in it. It says that growth or decay is a geometric sequence. It says U sub naught is initial amount. It says R is the growth, and N is the number of time periods. Often it's years, but we'll see what it is in the problem. And U sub n is the amount after n time periods. So it's like the final amount. Okay, so that's the equation that we're going to be using. I guess I'll just rewrite that right here because we will most likely need it. Okay, so example 11. The initial population of rabbits on a farm was 50. So initial amount was 50 rabbits. The population increased by 7% each week. So R is equal to 1.07. Now, the reason why we have to do 1.07 is because the 1 gives us our amount, and then the 7 adds 7%. If we just did 0.07, we would drop all the way down to 7% each rotation, or each time we went through it. It's important to have that 1 there. Now, it says how many rabbits were present after 15 weeks. So 15 is going to be our n value. So we're going to say U sub 15, the initial amount, which is 50, and then we're going to multiply that by the rate, and then we're going to raise that to 15. So we just need to open our calculator, and we say 50 times 1.07 raised to the 15, and we get about 138 when we round that. Okay, that's about it with that one. And then we do the same thing for 30 weeks. So this time 30, same starting amount, same rate. Just raise it to 30. Go to our calculator. Something cool in the calculator though, you can say second entry and everything's the same. And so we can just change that 15 to a 30, hit enter, and this is going to be 381 if we round that. So 381 rabbits. Okay, now part B says how long will it take for the population to reach 500? So we want our final amount to be 500. We still have the same starting amount, still have the same rate, but we don't know how long it takes. So we need to put a placeholder there, or I guess we could use n. Let's do that to be consistent. Okay, so we're going to go, once again, we haven't learned how to do this algebraically yet, and so we are going to graph it to find the answer. So we have 500, we have 50 times 1.07 raised to the x, and I already know my window is going to be bad, so come down here. We know our y max needs to be enough to see that 500, so I'm going to say it's 600. And I'm going to change this back to, let's see, maybe let's just keep it at 100. Let's see what happens. So crap. So there's our 500. We want to see where this curve crosses it. Okay, so it crosses. That's good. We just go second calc. Oh, maybe it's not done thinking. There we go. Second calc. Go to intersection, which is number 5. click on the first curve, click on the second curve, and then we want to guess. There we go, found the cursor, put it as close to the intersection as we can. And the intersection is at 34 approximately. And so we just say 34 weeks. Okay, that's everything. If you need additional help, please come to Math Lab. But for now, calculator.